We're going to look at Mersenne primes, which are of the format 2 to the n minus 1, and we're going to plug in the values 2, 3, 4, 5, 6, 7, and 11 and 13, I lied to you. And we're going to see if we can get primes from them. So if we plugged in 2, so instead of 2 to the n minus 1, if we had 2 to the second minus 1, so we put an n to be 2. Let me mark that off to the side here. 2 squared is 4, minus 1 is 3, and 3 is prime. Because it is of the format 2 to the n minus 1, we'd actually say it's a special prime. It's a Mersenne prime. I think I spelled that right. I think there's an E there. It looks like an A. I promise that's an E. So great job, Mersenne. And now let's plug in 3. So 2 to the third minus 1. 2 to the third is 8, minus 1 is 7. Hey, that's also prime, which makes it a Mersenne prime. Yay, so far so good. So let's try 4. What could possibly go wrong? 2 to the fourth is 16, minus 1 is 15. Sad face. This did not produce a prime number. So 4 did not work. Let's try 5. 2 to the fifth minus 1. 2 to the fifth is 32, minus 1 is 31. Hey, Mersenne prime. Awesome. Remember, go back to your sieve. We said 31 was prime there. If you don't believe it, let's try 6. 2 to the 6 is 64, minus 1 is 63, not prime. 63 is divisible by 3, 21, 9, 7, whole bunch of answers there. So let's look what's happening here. When we plugged in 4, we did not get a prime. When we plugged in 6, we did not get a prime. But when we plugged in 2, 3, and 5, we got primes. So what do you think we should only look at? 4 and 6 are composite, whereas 2, 3, and 5 are prime. So maybe when n is prime, we will get a prime number. So far, that's how it's looking. So let's try 7, which is our next number. 2 to the 7th minus 1, I don't know. I think it's 128, but I'm not sure. It is 128. It's 128 minus 1 is 127. I think 127 is prime. Let me try some numbers here. I think we're good to go. I think 127 is prime. Yeah, in fact, Mersenne prime. All right, so it seems to be working for prime, so let's try 11. 2 to the 11th minus 1. Well, 2 to the 11th is 2048. So this would be 2047 after we subtract 1. Oh boy, I have no idea if that's prime. Well, as it turns out, 2047 does factor as 23 times 89, sad face, so not prime. So it's looking that when it's composite, it doesn't work. We'd have to prove that. But when n is prime, it may or may not work. It may work. We can say that because it did work for 2, 3, 5, 7, but it did not work for 11. But if we try 13, 2 to the 13 minus 1, boop, is equal to 8,191, which actually is prime. So it's a Mersenne prime. So when n is prime, it may or may not work. When n is composite, it looks like it does not work. We'd have to formally prove that, or I'm sure it's in the book. You could read about it if you want to.